very quickly on your computers. So go to your desktop for the one, and we're going to open up Mag2dc. Let's check. I hope I have it here. There we are. Just to warn you, if you ever have problems running this, like if you've got it on the lab computers downstairs and something like you get errors, there was a remake of the software for Windows 7, and if you've got the old software on Windows 7 computer, you'll have problems. So just come speak to me if there are error messages. Okay, so on your desktop, double click on Mag2dc on the icon. Okay, and what we're going to load, everyone go to System Options and click on the first one, Begin a New Model. Okay, profile bearing is very important. So the orientation of your survey, don't ever neglect or think that this is not important, because gravity doesn't matter. If you're going north, south, east, west, your gravity will be the same, but magnetics changes. That's why if you're in the southern hemisphere and northern hemisphere, your magnetic anomaly will always be different. And if you're going east-west or west-east, it changes accordingly. I'll show you some. So for now, let's assume that we're going, a profile bearing of 0 means we're walking to 0. So 0 is, so we're walking north. Reference height of a 1. So we're using a walk mag. We're not flying in an aeroplane. Maximum depth display. Let's put this to 200 meters. It's just easier. So 200. Geomagnetic field parameters, these are the ones I spoke about before. So these are for South Africa. So what the magnetic field is around South Africa, we've got an intensity of 28,000, inclination of -60, declination of -22. It changes a bit from year to year, but for now we'll just use those default values. Okay, initial body susceptibility. Remember we said this is susceptibility contrast, but the background is probably close to 0, so you can kind of put in the body values. And you can leave it at 0.01. We're going to change it anyway. Okay, strike length. Your strike length in the bottom left, change it from 100 to 1,000. Dikes in general, we're going to model a dike, are not short. They go for long distances. So we're assuming that it goes for 1,000, and click for me over here on meters. So our units are going to be meters. In general, in the field, you're not going to walk more than 1 kilometer along a line. Sometimes it'll be longer. And then units, this just depends on the values you took in the field. But let's for now just click on SI. You can click on SI, so meters and SI, and leave this ticked, read in field data. So we're going to use data that is loaded in the program. Click OK. And there's really only one data set. So click for me on data and open. Okay, and now this first column here is the position data. It shows you that already. Is yours, have you got it? Mag. Position is in column 1. If you have Y data, you can put in column 2, but for now, this is actually just distance data, so distance along the line. And then you can see here, it says mag data in column 2, sorry. And number of comment lines is your number of headers. Just a tip, you always have to have at least one header line in this program. You can't put this value to 0. So always put a header. So yeah, so keep it at 3, don't change it. And then over here it says remove nothing, remove a value, remove an average. Sometimes in an area you get a regional field. So like it could, in general, the field is decreasing from this side to this side, and it's a regional thing. It's due to a larger body, so, and you're not measuring that larger body, you're looking at a smaller body, so you can take out that regional trend. It helps focus in on your smaller area, but we're not going to worry about that for now. Yeah, you can just leave it on nothing and then click OK. Okay, and then it says left button add corners, right button automatic body closure. Very, very, very important. You have to go clockwise. If you don't worry about having clicked on it, if you go anti-clockwise, your signal will be reversed and you cannot model this data set. So we're going to click Left button, we're going to put a rectangle representing a duck. So left button, left button, left button, left button, right button closes it. So that's fine, click OK. And then approximately in the middle here, go left button, doesn't matter what depth, and go in a clockwise direction. And then right click and it closes it. So everyone should have a pitifully small anomaly. Okay, and this is where you have to learn to start playing around with parameters. So this is obviously not fitting the data. So either this needs to be increased. So this is the data we measured in the field, we brought it back, we put it in the program. This small anomaly here is the anomaly created by this body. So something's wrong with this body. We need to make this anomaly bigger. How can we make it bigger? Any ideas? There's things you can change. You can either change the width, the depth, or the susceptibility. Those are really about the only things we can change right now. Maybe let's do this first. Everyone go for me to the top left here to edit the model, and then go down to change a corner numerically. It is the 7th one from the top. Change a corner numerically, or Control N. Okay, and these are the values at the corners of the body. So this, it's not so serious exactly how wide you make your body, but let's make it pretty and exactly vertical. So everyone put there for me 2995. 2995. And change your depth, let's do a depth of 4. So 2995 and 4. And then click on the next corner button. And so we've just changed this corner here, now we're going to this corner here. So let's put it at 3005. So at the moment our body should be about 10 meters wide, 3005, and again a depth of 4. Depth of 4. And then click next corner. And so now we're going right down to the bottom here. And the whole reason why we're doing this is because dikes in general come from really deep. So we kind of clicked here, here, here. So we're saying our dike is about 200 meters deep. Dikes are usually deeper than that. They really come from a long way off. So our horizontal position here was 3005, but you can change the depth to 1000. Maybe it's too much, but in general they come from deep down. Maybe it could even be more, but let's stick to 1000 for now. Click on next corner. And then this was our last one, which was 2995, and again a depth of 1000. And now I want you to click for me on calculate and watch your anomaly size, and let's see how it changes. Smaller. The reason why I got smaller was because we made it thinner. You can see the dike got thinner. But that's fine. Now we can play around with things. Click on OK. The third one down. Hey! That window there, so it's with the width and the depth of the body and the magnetic susceptibility. So that was this one here. So try play around with them. I'll give you a hint. Play first with the susceptibility value and try get your model to fit. I'm sorry. Show you, because it might save you time. When you're in this window, the left-hand side are the values, the current values. So the width is currently 10, the depth is currently 4. These values are the increments. So if I change this from, well, if I leave it at 1 and I push up or down, the width changes by 1. Whereas if I go here, let's change this to 10, then the width will change by 10. So it's nice that you could, instead of having to every time put in the values, you can actually just key in. And you can see that the anomaly changes as you increase the width. Strike length over here is at 1000. I thought I had changed it, but obviously not. It'll change it a little bit. And then I can close, okay. Okay, so first of all, can I just quickly show you how to move it horizontally? Maybe yours isn't exactly in the middle. You go edit the model, move a body near the bottom. And then this is a horizontal displacement, so moving left or right. Vertical is moving up or down. It's literally going to move it at a spacing of 295. You might want to make this just 100. And then you can try and move, or even less. And you can actually move it to left and right. So you would push up and down arrows. Make a dip on your body. here, underneath move a body is turn a body. So you would click on turn a body, and then this is the degrees, the angle at which you're going to rotate it. The problem that then arises is it doesn't keep your top surface exactly flat. But yeah, you can play around with rotating it and see how that will affect it as well. So this can literally, so I'd say everyone needs a susceptibility. I've got 0.05. What does everyone else have? I just found that 0.01 was too small. Okay, so you can have a highish susceptibility, and then width-wise, now up to 900. And you can see it looks terrible. I've got this weird spike leveling off and then this weird spike. The reason why it looks like this is because the only thing you actually see on magnetics are the edges of the body. The reason why that is because I'm seeing, there's a rock with low susceptibility, high susceptibility. Then it's all high susceptibility. There's no contrast, so that's why it levels out. And another contrast. I'm seeing the two at the edges. So the fact that your anomaly is quite flat in the middle means it's a lot thinner. It shouldn't be so thick. You're not really, in general, you're getting to the data. But we still don't know who the heck is actually right. None of you are right and none of us are wrong. There's so many different models of different susceptibility values. And so I remember when I was starting geophysics, I wanted to fit the curve exactly. You can't always fit the curve exactly. Sometimes to fit it exactly is not always geologically feasible, like your model looks crazy doing it like that. So you just have to get as close as possible. So what you could say to the client is, let's make this a depth of 5. So, you're saying to the client that if I have a dike at a depth of 5 kilometers or 5 meters depth, then it's probably about 400 meters wide. That's a very wide dike. Or you could say to your dike, if this body is deeper, let's put it at 15 kilometers. If this body, let's put it more. If this body is at 55 meters depth, then it needs to be a lot wider. You can see my body's coming up to 600 meters width. So I'm just saying to the client, look, if it's shallow, it's going to be this width. If it's deeper, it's going to be this width. Unless they've got boreholes, you can't tell them which one is which. So it's just giving you a range of models that fit your data. And there's no right or wrong answer. You've just got to have this range. Okay, so now you can see there are buttons on the right hand side. There's another way of doing it, but this is the quick way. Let's say invert. Yes, so this button here, invert. The computer's now going to calculate what is the best susceptibility to fit that curve. So you can click on your invert button and let's see what happens. Now it fits a lot better. Does yours fit better? No? Mine does. And it jumped up, I think mine was 0.05 or 6. It's gone up to 0.07. So it's just saying I needed a higher susceptibility to fit that value. But the problem is, I'm going to go back, I'm going to put this back to 0.05, my susceptibility, and I'm now going to hit the invert button next to depth. So now it's not going to change the susceptibility value, it's going to change the depth in order to fit the data better. Before I click invert, I'm just going to click on calculate. So you can all see this is my model, doesn't fit perfectly. I'm going to invert for depth now. Current depth is 55. I'm going to click on invert. Whoa! So it's pushed the body up to depth of 23. And that's still not a great fit, but it's better than before. Usually you have a value somewhere. It tells you how good your fit is, and the fit would have improved. So you can see now I can even hit the susceptibility invert button. So it's 0.05, I'm going to hit it. Oh, so it's jumped up to 0.06, and it is fitting the positive a lot better. So you can see there, first time I inverted for susceptibility, I got 0.07. Second time, I kind of did both depth and susceptibility, gave me a shallow depth, but not as high susceptibility. So these are the things that if you are a perfectionist, you've got a hard life ahead of you in geophysics, because Several things can be changed to give you an answer. That's why you go to the field and make measurements, because then you know, okay, my susceptibilities should be around this range. Can I show you the longer way to do the inversion that you can play around with by yourself? So everyone close that window and go for me here to inversion options. And go, the first one, oh sorry, second one says select body inversion parameter, click on it. So now you can choose, do you want to invert the horizontal position? Do you want it to move it that way? Do you want to invert the depth, the angle, or the susceptibility? In general for inversion, it's better to do one at a time. You could click on all four, but then you might get a really weird answer. So, I mean, yeah, it's better to do one at a time, see how each one changes. Maybe do two, but I'd say going to three is a bit crazy. But you might be. Horizontal position, everyone click on horizontal position, the first one, so it's ticked. Click OK. Click on inversion options again, and click on invert the model. You can see here, it's not going to invert for susceptibility. It is going to invert for horizontal position, not depth, not body rotation, and no corners. Click OK. Whoa, shifted mine completely over. See, this is the problem with inversion. So it thought it was a better fit. I don't know how, it might be a bug in the model. But you can play around with each of those parameters. Is there an undo button? Possibly not. That's the only other thing about that. Okay, because it's already 3 o'clock now, let's save this, and then you guys, if people need to go, or we can carry on, or you can carry on by yourself. When you save this, I would suggest if you're doing a project using this, save often. Because like you had with your project, it crashed. So go System Options, save the current model, click on it, and then just type your name and Mag2dc. Always give a decent name that you can find later. And then very important, you have to type the extension. The extension is .mod, mod. .mod. If you do not put that in, you will not be able to open it up again unless you physically go and add it in as an extension. So yeah, it must have .mod on it. Click Save, and it should say Model Successfully Saved. Some of the older versions, you might run into an error here. That is when you'll know that you've got problems. Okay, so that's the basics of the software.